In this video, we'll go over a simple Simon game which was designed using C language, KLU Vision software, and a circuit as you see in the video right now. The purpose of this video is not to go over the code. However, if you are interested in seeing the code for it, you can click in the link below, which will take you to a GitHub link, which have all the details about the connection of this circuit, plus the code as well. So let's start describing what do we see right here. So we have STM32 F103 and we have a breadboard over here. We have our breadboard which is taking 3.3 volt from the STM32 and taking ground as well, okay, with these two wires. And then on this circuit we have the 4 push buttons. Each side of each one of them is connected to ground, so we can see 3 wires here going to ground to each side of the buttons, and the 4th one is getting a ground over here as well, okay. And then the other side of the buttons, they are going through 10k bus resistor, so they are going through the resistor 10k ohm, and then they are going to the STM, okay. So these are our input to the STM32, 4 wires over here, okay. These 4 wires, will come back to them later to describe what ports actually they are connected to, okay. Now let's stay here in the breadboard. We have 4 LEDs, so they are in order, so the white representing the black, red for red, green for green, and blue for blue. So they have a common cathode, so all the cathodes connecting to ground over here, and then the other side is going through isolated resistor, which is 270 ohm. We can see it over there, okay. And then each one of them is going to the STM32, and these wires, the yellow one over here, is our output from the STM32 to the LEDs. So we have push buttons which will have the input, and then the output will go to the LEDs, okay. And we have one light over here which is a red light. It's also connected the same way these are connected. It's taking a cathode to the ground, and the anode is going to isolated resistor which is 270 ohm, and it only have a different port number for the STM, and it's actually going as, it's also taking output, but it's only responsible for failing sequence. So if the player fail, this will be flashing for 3 seconds. Otherwise, our game will be based on these 4 buttons, or sorry, these 4 LEDs and the 4 buttons. Now coming to our STM32, we have these 4 wires are going as inputs, as we said. So all these 4 wires, the blue ones, the 4 one, not that one, they are connected to port B, and the first one, which represents the first black button, it's connected to pin 4, the second one to pin 6, and then pin 8 and pin 9, okay. And then we have this wire which is going to the failing light. It's going to actually let me check it. Okay, so it's going to D12, and D12 in our STM is represented by port A, pin 6, okay. And then we have the yellow wires which is also connected to the STM32. These wires are the output of our STM. So the first, they are in order here from, we can see them, let's make it a little close. Okay, so the first one is going to A0, A1, A2, and A3. Okay, so A0 and A0 all the way until A3, they are represented in the STM32 by A0, port A pin 0, port A pin 1, port A pin 4 for A2, and for A3 we have port P and pin 0. Okay, so now let's try to run the game and see how it works. So if we press the running part, these lights will go right to left and keep going like this until we push the blue button in the STM, and that's when it will tell us ready, set, go, and then it will generate a random number and it will push it to the LED. So one LED randomly will be generated for us and lighting up for less than a second and turning off back, and then we have to mimic that by pushing the right buttons. If we did it correct, it will generate more lights for us, and we just have to keep going with that correct sequence. If we failed, it will flash for 3 seconds, and then we'll get our result in binary by these 4 LEDs. So let's try this. Ready, set, go, and then let's try it. And then if I press the wrong one, I'll just fail, and then I'll see my result. So it's 0010, which is 2 in binary. Okay, so that means we win the first one, win the second time, and then we failed. Okay, let's try it again now and try to win them. One, 2, 3, 4. Okay, if we win all the 5 which is designed until now, all the lights will be flashing on and off. That's mean we won the game. And now we only arrived to level 5 and then we won the game. The goal is to make it for 10 rounds. Okay, I only made it 5 right now because when I did it for 10, it was very hard to keep winning until you arrive to 10, and we don't want to keep repeating on the video. So I made it to 5 to make sure that the win sequence is correctly implemented. And then now what we can simply do, we can go to our code and change the 5 to 10. Make sure it's saved. So we save all, and then we rebuild, load, we make sure it's loaded to our device, and then whenever we win the 5 level right now, we should not stop. We should keep going, and it will keep generating different lights until round 10. If we win 10, we'll flash all of them on and off. Otherwise, we will just get the result for wherever we arrived. So let's try this. 1, 2, 3, 4, 5, okay, I failed. Okay, let's see our result now. So we have 0, 1, 0, 1. So that means we finished level 5, we won it, and then we failed it when we are trying to win level 6. So now it's going for 10 rounds. It will keep going for 10 rounds. We can make it more, but the purpose of this project is to make it only for 10 rounds. Okay, so that's everything we have in this video, and if you're interested of seeing the code for it, you can hit the link under the video to see all the details for connections and the code as well.